Hello everyone, welcome back to another SATs preparation video. Today, we're going to be taking a look at the problem solving paper in maths, some of the trickiest questions around, and we're going to be breaking down exactly how to answer them. But we're going to be not looking at just area, but volume as well. Why are we doing two in one video? There's a really good reason. I want you to keep an eye out later on and I'll explain exactly why. So why could we be doing two? Well, let's start off with some area questions. And straight away, I wanted to put this one in. Why? Well, anyone who's been watching our other videos, and if you haven't, by the way, make sure you do, will notice that we've already looked at this question. And the reason is why. We haven't done an area video yet. And it says right here, calculate the area of the square. Clearly, this is an area question. No, I covered it in our perimeter video. So if you haven't, go and watch it. It's really good. I would say that, wouldn't I? But, you know, it is a good video. It's going to help you answer lots of perimeter questions. But in that video, we talked about how in the SATs paper, in the problem-solving questions in particular, we'd like to have more than one strand going on at once. And this shape very much relied on you understanding what perimeter was. So I could have put this in the area video. I'm not going to solve it. If you think you want some help to solve that, go and watch the other video. I explain exactly how to do it. But I just wanted to remind us that, okay, there are obviously going to be some overlaps, all right? So in this video, I went through every other SATs paper from 2016, and I drew out all the other area questions that we haven't covered yet when it overlapped other things. So here's one, okay? 4 of the triangles have the same area. Which triangle has a different area? And the first thing straight away, when we see the area of a triangle, we should be thinking half base times height. That is the area of a triangle. Okay, so when you think about the height of a triangle, it's just that. How tall does it stand when we put the base down along the floor exactly like that, perpendicular? Not perpendicular, sorry, parallel to the ground. We'll go on about perpendicular and parallel in a future video. Pay attention for that. But we need to make sure we know the height of the triangle. And then we multiply it by the base, which is this one here, parallel to the ground. And then we halve it. And you might be thinking, oh, I recognize base times height. Yeah, because base times height is the area of a rectangle. So they are very much linked. Here's why. We can cut a rectangle in half to get a triangle. It's as simple as that. So that's why we halve the base times the height when it comes to a triangle. So here, okay, how can we work out the area of this? Well, first of all, luckily we are given a grid, which makes it really easy. Because my number one technique for this would be to turn each triangle into a perfect rectangle. You can see here we're doing it for A. This has 1, 2, 3, 4, 5 squares, which we now have to half. So this has an area of 2.5 squares. Let's go to B. I can already tell this is going to be different. So the answer is A or B. Because for B we have 1, 2, 3, 4, 5, 6 squares, which we need to half, gets us to 3. This is going to be really easy to solve now because we only need to find out C. 4 of them have the same area after all. So whichever one this is the same as, the answer is the other one that's remaining. Let's draw around here to make this into a rectangle. Cool. We have 1, 2, 3, 4, 5, 6, which we need to halve. Therefore, C has an area of 3. You could waste time and do the rest, but you already know 3 and 3 have duplicated, so the rest must have an area of 3 also. That means that A is the one with a different area. Okay? So what do I need to know to be able to solve this question in the future? Well, you need to know how to work out the area of a triangle. By the way, you're going to need that for a question later on. So make sure that's embedded in your mind. Base times height for a rectangle or a square, and a square is a type of rectangle. Again, we'll do a whole geometry video in the future. Half base times height for a triangle. That's simple, easy, right? Let's take a look at another question then. A square tile measures 20 centimeters by 20 centimeters. It's this one. As always, I would be writing down any information, jotting it down so I'm not thinking, oh, I'm going to have 7 million different numbers in my head. No, just write it down, use annotations. Again, this is kind of, because we're looking at shape, aren't we? It could come under measurement area, obviously, but we are looking at shape here. We need to know what it means if something's a square. Well, it's 20 by 20. Luckily for us in this question, it does actually give us that. So it's not relying on just our knowledge of squares, but we know what a square is. 20 by 20. A rectangular tile, this one next to it, is 3 centimeters longer. So I'm straight away going to write that down. What's 3 centimeters longer than 20? Well, it's 23. And 2 centimeters narrower. This is the key word. Now, in the SAT paper, you have to know your mathematical vocabulary. What does it mean to be narrower? Well, it's the opposite of wider. So it's narrower, the number's getting smaller. 2 centimeters narrower, therefore it's 18 centimeters wide. Cool. I've done my jotting down. I don't even know the question yet, but I'm in a good place. What is the difference in area between the two tiles? There we go. I said to you earlier, the area for a rectangle is base times height. We need to know that. Luckily, we do, right? So now we can work out this question. Have a go at working out the area of both, and then I want you to see if you can get the right answer, which is the difference in area. I'll show you how to do it after. Okay, so for 20 multiplied by 20, you could use your times table facts. 2 times 2 is 4. And then obviously we have 20 is 10 times bigger than 2. And this 20 is 10 times bigger than 2. So it has to be 100 times bigger than 4. So we have 400 centimeters squared. Nice and easy. 23 multiplied by 18 could be a bit harder. Well, by the time that we are taking this paper, we'll have a fantastic understanding of long multiplication. So we can simply split 18 into 8 and 10. 8 times 3 is 24, exchange over the 2. 8 times 2 is 16, plus the 2 is 18. So we have 184 there. And then multiply by 10, simply put a placeholder, 3 times 1 and 2 times 1. We add them up to find the total. 8 plus 3 is 11. 1 plus 2 plus 1 is 4. We have 414 centimeters squared. That's the answer, right? We finished there, right? We get our answers right. No, we don't get any marks. Because remember, we have to do every single step in a question to get even 1 mark. So what's the difference in the area between 400 and 414? This is something where genuinely we don't even need to try working out because it's obviously 14. So the difference in area is 14. Make sure if it's there already in the answer box that says centimeters squared, fine. But if it's not, make sure you put your units. We've solved it. Simple. These area questions. Wow. I bet there's loads more. No. This is flabbergasting to me. I went through every single SATs paper since 2016. 2016, 2017, 2018, 2019. Bit of a gap when we didn't have any tests for a few years. 2022, 2023. That was it. That's it. Think how much time we spend learning about area in our maths lessons. And that is it. So something to think about here. Yeah, we need to be confident with area. But the main way it's going to be tested is through proper problem solving. So the best way to spend your time is to practice problem solving questions. Yeah, of course, you need to know how to work out the area, but it's about applying that to questions we've never seen before. So I was thinking to myself, okay, if the most important thing is applying our understanding of area to questions we've never seen before, and we need to know that the area of a triangle is half base times height, and we need to know that the area of a rectangle is just base times height, you guys have all that knowledge now. So what could I do to make this video pad out a bit? Well, like I said earlier, we're going to look at volume as well. But for now, only 8 minutes into this video, I made up a question. So here's my SATs question. The Dylan SAT. Can you solve my question? I wouldn't be surprised if we get a question like this come up in the future, because this is using all of your knowledge of area, applying it to a problem-solving question. Now, I love this question because there is also a quick method to work it out. When I write problem-solving questions, I like there to be a method everyone can do and a much quicker method that rewards people who can see the shortcuts. Guys, have a go at my question. See if you can get the right answer. So I've kind of sprinkled in little hints as we go. So let's take a look. We have a triangle here. Thank you for labeling that, Dylan. Very useful. And a square. Now, what have I said to you so often? If it says square, it's usually going to be relying on you knowing what a square has as its properties, which means that I can label the height straight away. That must also be 4 centimeters. Okay, so let's keep going from there. These two shapes are the same height. Aha! Let's stop and apply each sentence as we go through. That means that the height of this triangle, wait a minute, that's going to help me, isn't it? The height of this triangle is 4 centimeters. Wait, half base times height. Okay, and base times height. We need to know those. It's going to help us, I'm sure. Hayden, always making patterns with shapes, that guy. Hayden makes a pattern using the shapes above. So it's these exact shapes. So we can apply the measurements at the top, down to the bottom. What is the area of this shape? Fantastic question. Who wrote this? Absolutely brilliant. Well, let's start with the 2 squares, okay? The area of 1 square is 4 times 4. Just use your times tables. Is 16 centimeters squared. We have 2, so I'm just going to label both as 16. We are on 32 centimeters squared if we were just counting the area of the squares. All right, now we've got 2 triangles. Well, what's the area of 1 triangle? Well, half base times height. Let's do base times height. 6 times 4 is 24 centimeters squared, but then I need to halve it because the equation is half base times height. So half of 24 is 12 centimeters squared. Each triangle is 12 centimeters squared. 12 plus 12 is 24. We have 32 plus 24, and we get the answer 56 centimeters squared. Now, I spoke earlier about the fact that we could use shortcuts to help us. We have two triangles. Okay, so half base times height. We have to do that twice. That just means we can get rid of the half. We could have just done 6 times 4. 6 times 4 is 24, and look, that gets us the area of both triangles. We could have skipped a little phase there. Wouldn't have saved much time, but it's a nice little nod to that if you can see those shortcuts, why not use them? But guess what? We can solve it, 56 centimeters squared. I need you right now to pause this video, go down to the comments and type yes in capital letters if you got my question right, because I'll be very proud to see how many of you managed to do that. But like I said, obviously the first half of this video was all about area. So we spent about 10 minutes doing that. We've realized that there's not really much area that comes up in this test, but it does come up in problem-solving techniques. It needs problem-solving techniques to solve them. So hopefully that's good practice. Let's move on now to volume. So we talked about area as the space taken up by a shape. Volume goes from 2D to 3D. It's almost like 3D area, but I'd never say that because we don't want to get confused between volume and area. Volume is the amount of space something takes up in three-dimensional actual pickup, and I can see, and I'm talking about this big bottle of water has a volume because it takes up real space, okay? Now our question's written on paper, so we have to imagine these are 3D shapes. Write the letter of the cuboid that has a different volume from Emma's cuboid. Emma's cuboid's right here, by the way, and the information is Emma makes a cuboid using 12 cubes. That's how much space her cuboid takes up, 12 individual cubes. What is the letter of the cuboid that has a different volume from Emma's? Try and solve it yourself, and we'll see how to do it after. So the simple version is, this is as simple as volume gets, really. It's counting blocks. But the problem is, look, we can't just count the squares we see because we know we're not counting squares. We're counting 3D shapes. So this whole cube here on the right that I'm going around here, that's one cube. Okay, and if you can't imagine that, I would say get some multi-link cubes, get some real-life dice, stack them up, and just notice what you can see because some of them are hidden. Now we have 3 cubes lined up here. That's 1, 2, 3. 1, 2, 3. 1, 2, 3. And then actually back, we must have 3 more going down. They're completely hidden, but we need to have spatial awareness of what's going on. So here we have our 12 cubes in total, even though some are hidden, but it's a full cuboid. So the question is basically, which of these cuboids does not have a volume of 12? Which of these cuboids does not use 12 cubes to be made? Let's look at E first because it's nice and long. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That is the same. Do not count twice. Remember, this is 1 cube. This is 2 cubes. They're just hiding behind the cube in front. Let's look at D now. Well, I can see straight away D is just a rotated version of Emma's. This is just like Emma's has just been flipped on its side down there. So we have here 12 cubes. It's not D. Another way to think about volume, guys, just so you know, we can multiply the base and the height, just like area, but then with 3D we add the depth as well. So for example, here would be 3 times 2 times the height, which is 2. 3 times 2 is 6 times 2 is 12. There we go. We can use a mathematical equation. Here, let's do the same thing. It's 2 across. It's 1 deep, and it's 6 down. What is 6 times 2 times 1? That is also 12, so it's not A. Let's look at B. Well, straight away, again, I can see B and A are the same shape. They've just been flipped. Let's just make sure. 1 down, 2 across, 6 deep. 6 times 2 times 1 is 12. It must be C. Let's really hope so, right? So we have 3 across, 2 up, and 3 back. 3 times 2 is 6, times 3 is 18. Thank goodness it was C. We'd circle that and we'd move on. So just to recap, to work out the volume of a cuboid, we have the base times the height times the depth. We need 3 measurements. And if you weren't sure what the units would be, instead of centimeter squared, which was for area, we have centimeter cubed this time. Why is it a 3? Well, because we are multiplying 3 measurements together and it's in 3D space. Why is area a 2? Because you're multiplying 2 measurements together in 2D space. Hopefully that helps you to remember. So a bit more abstract now. We're not counting individual cubes anymore. We kind of just have to imagine the cubes there ourselves. So, for example, this is 6 centimeters wide here. This is a cube. And what do we know about a cube? In the same way that a square has the same sides, a cube has the same length edges. Again, we need to know these geometry terms. These questions rely on us having extra knowledge from other strands and applying them to new questions. Cube A and cuboid B have the same volume. This is given to us and it is key information. That is all I'm going to say to you, other than we do base times height times depth. That's written in many different ways, by the way. We have width times height times depth. Whatever it is, the three different directions of the cuboid is what we multiply together. Just so you know, cube, like I said, the same length edges all the way. I want you to have a go at this question yourself. If you're feeling overwhelmed, just give it a go like you're in a test. Like, do some maths, see if you can get an answer. It's always the best thing to do. But I will obviously go through it with you afterwards as well to see how you go on. Now, what I am going to do straight away is just draw a big equal sign in here. Okay, a huge equal sign right in the middle. All right, and why am I doing that? Because, well, I need to know they have the same volume. So whatever I work out here has got to be the same over there. Calculate the missing length on cuboid B. What will this be? Get it? What will this be? Well, firstly, let's work out the volume of the cube. You might be thinking, how can we do that? We only have one of the edges. I just told you, all the edges are the same. So to work out the volume of this cube, we have 6 multiplied by 6 multiplied by 6. 6 times 6 is 36. Then we have to multiply it by 6 again. Use short multiplication, guys. Just make sure. You've already just done 6 times 6, so that's going to be 36 again. 6 times 3 is 18, plus the 3 is 21. This cube has a volume of 216 centimeters cubed. Guess what that means? We know the volume of this cuboid. The answer to whatever the question is going to be 216 centimeters cubed. Okay, nice. Well, how am I going to work out this question mark? Write it in. Because to get to this answer, we're going to have to do 6 multiplied by the height, 4, multiplied by whatever this is here, something. Let's simplify this a little bit. Let's do 6 times 4. We have 24 multiplied by something equals 216. A few ways to do this. You could do 216 divided by 24. You can use long division if that's something that you're used to doing, but it's not going to be very effective, okay? Because the answer is less than 10. So that wouldn't be the best method. A really good method here would be to use trial and improvement. For example, could it be 10? So 24 multiplied by 10 is 240. Very close to 216, but a bit too much. So that what I would say straight away is try 24 less. 24 multiplied by 9, and again, put it into short multiplication. If you have good number sense, you'd be thinking 9's a pretty good guess. 9 times 4 is 36, ends in a 6, which is always good. 9 times 2 is 18, plus 3 gets me to 21. It is 9. So that works beautifully. 24 multiplied by 9 is 216. So the only measurement that works in here would be 9 centimeters. Going to show you a really quick method that some of you may have noticed yourself. I'm actually going to write out the question. When I say question, the working out, okay? So the volume of A is 6 times 6 times 6. And that's the same as the volume as B, which is 6 times 4 times something. That's what we had when we started this question. Well, because these are equivalent, we can cancel out one of the 6's each. Times by 6 times by 6, that's the same. Just drop it. It's going to give you the same answer. And it leaves us with 6 times 6 is equal to 4 times something. Well, 6 times 6 is 36. 4 times what would equal the same? Yeah, if you know your times tables, it's 9. And look, it's the exact same answer. So much quicker method there. Problem-solving questions are amazing when it rewards quick shortcuts. It's a fantastic way to answer this question. But guess what? We also know the long way that we will definitely get an answer. So it doesn't matter which one you pick. As long as we end up getting the marks at the end, that's all that matters. So this is, I love this question. I love this question. This is the net of a cube. 20 centimeters. Oh, but what is that 20 centimeters actually measuring? Is it measuring the side of one of those squares, one of those faces? Because remember, these edges of this 2D shape actually, in the end, when it's folded, will become the edges of the cube. Okay, so imagine this is the cube we make. We need to work out the volume of this cube. So the only help you're going to get is you need to somehow work out what would the height of one of these edges be, what would the width, and what would the depth. And remember, it's a cube, which means these are squares. Can you solve it? Classic trap for this question would be to go, 20, so I just do 20 times 20 times 20. No! Because realistically, look, use our spatial reasoning here. This net is going to fold into this cube. Now, the height of this cube is not 20. That's just not going to work. What I need to actually know is the length, rather, of one of these sides. How can I work that out? Well, we know squares all have the same length sides. So if we keep going down, each arrow that I'm drawing is the same length. Now that is always fantastic for division. When we divide, we have equal parts. So if each length is of equal length, then we can just simply divide by 4. So I take 20, which is the height of everything, and divide by 4. And that means that each side of this square is exactly 5 centimeters. Now I can measure, I can label 5 centimeters over here. And because it's a cube made up of squares on each face, that means this is 5 centimeters and this is 5 centimeters. We're one step away from solving this problem. How do I work out the volume? I do the base, which is 5. I do the height, which by the way is 5 because it's made up of squares. And I do the depth or the width or whatever you want to call it. It's 5 again. 5 times 5 times 5. 5 times 5 is 25. Multiply that by 5 is 125 centimeters cubed. What a fantastic question that is. I love it. So this is the last one that I found for volume. Again, there are not many questions, right? I went through 16, 17, 18, 19, 22, 23. That's 6 papers, which is actually 12 papers because there are 2 reasoning papers each year. 12 papers, and this was what we got for area and volume. Something to consider. Guys, I'm not even going to read this. I'm going to let you pause it and have a go yourself, and then I'll read it through and solve it together before our final question that I'm going to show you after this. Stick around. Okay, so Amina made this cuboid using centimeter cubes. That means that each cube, if we say a centimeter cube, it just means that the length of each edge is 1 centimeter. Okay, so that means the volume, Mr. Price, the volume is 1 times 1 times 1, which is just 1 centimeter cubed. Okay, so that's what a centimeter cube is. Stefan makes a cuboid that is 5 centimeters longer. I'm going to do this straight away. Okay, so literally I'm going to draw a cuboid here, 5 centimeters longer, so that's 11, because 6 plus 5 is 11. So it's 11 centimeters longer. 5 centimeters taller. Well, this is 4 tall. So adding on 5 is going to be 9. Look, I'm drawing it as I go. I don't even know what the question is yet, but I'm going to draw as I go. It's the best method. So that I can just draw this face in like that. It's 11 wide, 9 tall, and 5 centimeters wider than Amina. So let's, in this case, we say wider. I'm going to go back for more 5 because I've added on 5 to 4, added on 5 to 6. I'm going to add on 5 to 3. So this is going to be now 8 centimeters. And I can draw in the rest of my cuboid as a rough guide. Cool, so this is Stefan's. This is Amina's. What is the difference between the number of cubes in Amina's and Stefan's cuboids? Now, quick bit of help. The number of cubes is simply the volume in this case. Because whatever we work out as the volume, each cube is worth 1 centimeter cubed. So for example, if the volume was 20 centimeters cubed, you'd need 20 of those cubes. Okay, so it's the same thing. So let's firstly work out for Amina how many cubes she has used. Let's do 4 multiplied by 3. Remember, it doesn't matter which order, but 4 times 3 gives me 12. And I know my 12 times table. And I'm going to take my 12 and multiply it by the 6. 12 multiplied by 6 is not 90. What's going on? It's 72. So Amina's is 72 centimeters cubed. That means she used 72 cubes to build it. Okay? We know this because it's 24, 24, 24. Okay, so we could sit and count them up and try and work it out. But you know what the best method is? Use the equation. 4 times 6 times 3. Cool, got it. Now we need to work out how many cubes Stefan made. You might be shocked by the difference. So let's take a look here then. What's going to be easier to multiply at the end? Well, I know my 8s really well. So I'm going to do 9 times 11 first. It will leave me to multiply that by 8. 9 times 11 is 99. So I'm going to draw 99 here. And then I'm going to multiply that by the remaining side, the remaining edge, let's say, multiplied by 8. 9 times 8 is 72. I'm going to exchange over the 7 to the 10s. 9 times 8 is 72. Add 8 is 80. So we have 802. Oh my goodness me. This is crazy. Stefan used 802 blocks on his cuboid. All we did was make it 5 centimeters longer, 5 taller, and 5 wider. That doesn't seem like much. But look at the answer to this question. What is the difference? Well, we're going to take 802, which I'm writing here in the middle. We're going to subtract 72. 2 take 2 is nothing. 0 take 7. Let's just do some exchanging to make sure we get this right. 10 take away 7 is 3. And drop the 7 down. Oh my goodness me. In order to make his cuboid 5 centimeters longer, 5 centimeters taller, and 5 blocks wider, because it's the same thing, Stefan needed 730 extra blocks. That is mind-blowing. And this is what happens when we move into the third dimension. Yeah? He had to have a lot more blocks. Absolutely mad. Before I talk through this question, very quickly, guys, can you leave us a like? Can you please comment, let us know what you think? Did you get my question right? And I want you to comment on this video to see also if you can solve this one for me. I've taken a question from the sats that we've looked at in this video. I've slightly altered the measurements. Can you apply what you've learned today? And please do share our videos. We put a lot of effort into them, guys, and I know you like them. Keep asking us for more. Keep telling us what to do. And guess what, guys? We will do it for you. So thank you so much for watching. We really appreciate you. And I can't wait to see you next time.